be, which is,
Team Kuukulgur is setting up. They're from Estonia, and Kuukulgur is Estonian for lunar rover. So it should be interesting to see this team set up for again today. They have a swarm tactic robots, so they're going to have 3 robots that should drive around and try to find the sample and return. So we'll see how they do. Okay, that's the whistle of Kuukulgur's run. Let's see how they're going to do. They're got a 2-minute power-up sequence that's going through. See what's going on with the platform. They got 3 different robots that are going to be going out and wandering around the field to try to find the samples. This is their second run. Yesterday they were out and about looking around, and they did try to find stuff. Okay, here goes number 1 releasing. Number 1 didn't make it off the launch pad yesterday, so it's doing vastly and better. And now it's stopped. So why do you guys think that robot stopped?
It's supposed to stop.
It's supposed to stop?
It will calibrate something, it will calibrate sensors, and then it will continue.
All right, so it drives off, calibrates the sensors, and then goes forward. So what do you think it's doing right now?
It's going to by its pre-programmed path towards the precast sample.
Okay. That's cool. This should be interesting to see. You think its wheels are getting caught up and that's why it turned around?
No, probably it's a false positive obstacle.
Okay, so, and that's why it's heading home? Or it's just trying to find a path around?
It's trying to find a path around.
Okay. How do you think it's going so far?
Well, not too bad and not too good.
Right.
The first robot probably saw a lot of obstacles on its way that were not actually really there, and that kept it delayed. So the second one started, but then we timed the starting sequence so that the first robot would be quite some distance away already by the time the second one starts. But now the second one started when the first one was just struggling with like ghost obstacles that weren't really there, and that's why the robots, I think, almost hit each other. But now it seems that the first robot is a little bit lost, but the second robot goes right in the direct path towards the free cache sample. So that should be better.
Well, that's good. The first robot is actually doing a little bit better than it did yesterday, since the first robot didn't make it off the pad yesterday, right?
Yeah, and the third robot should be starting in maybe 30 seconds or something like that.
All right.
The second robot's now actually going quite directly towards.
Yeah, he's doing pretty good. He's making his way right there towards that sample. So when does he start his search algorithm?
When it gets to within about 3 meters of the predetermined location, which I think is quite close now.
Okay.
But I think the major difficulty for us, or the major risk for us, is the steepness of the terrain. I think the pre-cache sample is pretty much on the steepest part where it could be, and this is something we have difficulty with.
Okay, I can see that.
So even if they so what happened yesterday was that our robot got very close to the sample, but it couldn't home into the sample accurately enough because of the steepness of the terrain, and this is something that could very well happen today as well. So it's very close to the sample. It could get even closer, but maybe it is not able to grab it. So now it actually it didn't notice. Probably didn't notice the sample.
All right. So the third one looks like it's making its way out there.
Okay, in the right direction.
So it's going good.
Yeah, but the first one has something mixed up there. I don't know what, but it's not in the right place where it should be.
And the second one seems like, I mean, the third one looks like it's trying to get it around that little hole there.
Difficulty with the hole, but I think it will be okay. It oriented itself fine. I think it knows which direction the pre-cache sample is, so it should negotiate the hole I think, pretty well. It might
Hopefully.
take it like a minute or something, but it should be okay.
It's trying hard. It's going to get out of that hole. So robot number 2 is still trying hard. I think it's went up and went down the hill, so it's still looking around. So what did you guys change overnight?
Software changes. Quite a lot of software changes. We improved the detection algorithm for the orange fence we have, because running into that will cause an e-stop by the judges, and we improved that. We knew it wasn't ideal, but hopefully it's better now. Then we replaced one of the motor controllers that had failed.
You think that's a spot? You think it's seen a thing?
Yeah, I think it's seeing it. It also saw it last time, yesterday. It saw it pretty well and pretty close.
All right, it might be getting it. It might be getting the sample.
It's actually hard for it to grab it on that steepness level.
Right. Well, we'll see what happens over here. Do you want to look at the video camera to see if they have a better view over there?
Yeah, that'd be nice. We certainly saw the sample, that's for sure.
Well, that's good to see that your recognition is working.
Okay, it's starting to grab it. Yeah. No, that's sorry.
Can you just move over a little bit? One of the cameras is far away. And you're in the path.
Let's see whether it misses it or not. The problem is with the steep terrain, it misses. Oh, it actually grabbed it?
Yeah, it looks like it has it in the...
Or maybe it has a good,
Yeah,
it has a good grab.
It's got it. It's got it. So now we'll see if it can return home successfully. You got to be proud of that accomplishment.
Yes.
And now one of his brothers is coming over to congratulate him before he gets home. So how does your robots deal with moving obstacles?
It doesn't.
Do they know about each other?
Okay, well,
No.
I believe yesterday you had said that it treats the other robots as if they're obstacles in its path. So
Yeah.
So-
So that's what they're doing right now. They both saw an obstacle, and they're trying to avoid it, but they have no idea that the obstacle is moving. So
Okay. All right. Hopefully that. All right. Well, your robot still has it, so you've
the
accomplished.
rover still has it. But
half the
why did
objective.
Why is it waiting now? Is it still avoiding that?
Oh, maybe it's because the other guy drove right in front of him and he thought,
Yeah,
oh, there's something in front of me again.
Yeah, exactly. It thinks there's some obstacle, but maybe there's also some other problem.
Maybe.
It should be going about now pretty easily, but it isn't.
You think it's the grass that's messing it up over there?
Maybe.
You think it's a sample that's dragging a little, maybe?
Maybe, but it should be pretty easy going from from that point on. But it doesn't seem to be the case.
You think it's confused about which direction's home now?
I hope not. That would be quite painful. But I hope it's just battling with the obstacles, which should be a temporary problem. How much time do we have left?
Yeah.
20 minutes.
20 minutes.
All right, so we got 20 minutes. Should be plenty of time left.
Yeah, so even if it's just battling with obstacles, then it should be enough.
And if it,
has some other problem, then it may not be enough.
hopefully, it won't get close enough to the orange fence that you'll have to see how that algorithm worked out for you.
I hope so. We didn't test that a lot.
That's understandable. So your other robot has made it to the location of where the pre-cache sample is, and he's looking around confused. So, but as long as he stays out of your other guy's way, it should be okay, right?
Yes. The robots, they actually ignore the fact that the first one has collected the sample already. because this information could be faulty. Like I think Team Spacepride told us yesterday that their robots both thought they had grabbed the sample yesterday, but actually neither of them did.
Right. So, but they went through their collection routine, so it's behind that tree over there. It looks like it's so would it still be looking, what would your robot be doing now that it has a sample?
It would be returning. It should be returning to the home base, and
Right.
it should start seeing the visual markers in about midway. Right now, it certainly doesn't see the base, but it should start seeing it. So the first question is that will it make it to the point where it actually starts seeing the home base?
Right.
But right now, it seems that it's battling with obstacles.
Right.
How does it navigate before it sees the marker?
Odometry, actually. We have four-wheel drive, so it's actually pretty accurate just to calculate by the wheels.
So it's using the odometry to keep track of its orientation?
Yes, orientation is via gyroscope, and we spent quite a lot of time denoising and debiasing the gyroscope and calibrating it. So it's actually calibrating the gyroscope while it's moving and while it's standing. So not just in the beginning, as a lot of other teams are doing, but also while we are moving. So that's why we are, I think, more accurate with orientation than some of the other teams. But let's see whether that's enough.
So I got a strange question for you. Do you think the weight of the sample is throwing off the robot at all?
Sorry?
Do you think the weight of the sample is throwing off the robot at all?
Maybe. The grabber in the front is very heavy. So if you add the weight of the precast sample, it might actually cause the robot to hit the terrain a little bit.
Okay.
It might do that in like tall grass and things like that, but here it's not very tall grass here.
Well, not to us.
Yeah, not to us.
But in terms of the robot, the grass is like up to our knees. So,
Yeah,
I
something
mean,
like
that would be tall for us.
Something
So,
like that. But right now, it seems that the robot has a reasonably good idea on where it is and where the home base is, but I think it's battling with ghost obstacles.
okay, well, it's not the smoothest of terrain out there, so it's still working with
Right now, it got to a pretty smooth part of the terrain.
Yep. So it should be looking around to try to spot your base, right? That's what it should be doing right now, I guess.
Yeah, the other possibility could be that it's spending quite a lot of time there, so maybe it actually thinks the base is there. It's possible that it goes to search for the home base. Let's see what it's doing right now. I can tell probably within some time whether that's true. It actually seems to be true. It thinks the home base is there.
So does that mean it's not looking for? It's still looking for the markers.
It's still looking for the markers, but it doesn't know where it is. So it recognized that the home base is not where it thought it is. So it actually thought the home base is where it spent quite some time over there.
Okay, so is that because of the patch of the dirt over there?
I don't know.
maybe?
I don't know. It's probably that it mistook some other object here for a visual marker, and thought that the home base is there. Now it actually recognized that the home base is not where it thought it is, and now it goes about searching randomly, essentially for the home base.
Okay.
And it's actually quite far away from the home base, maybe something like 50 meters, 45 meters. So it's a matter of time and matter of luck whether it gets within the visual range fast enough.
Well, I know you have a lot of people over there behind the fence rooting for you, and a lot of people here, and a lot of people on the webcast rooting for you, hoping that your robot makes it back to the base in time. But it covered a lot of ground right there, so who knows if it keeps doing that circle pattern. It's going to eventually make it back to base, and one hopes.
Yeah.
There's about 15 minutes left.
Yeah. It should be it should be enough time if we have luck. If we are lucky, then it should be enough.
Well, you already grabbed the sample, so that's good.
Now it went on to pause.
Is it because the robots are spreading out?
Yes, that's definitely a factor there. But we made a lot of improvements actually on that last night.
Oh, that's good. What did you do to change that?
We increased the transmitter power.
Okay.
We discussed with the judges in greater detail what's within the limits of the rules and what's not within the limits, and decided that we had been a bit too conservative for the rules. That we could actually go a bit further.
Okay.
So we increased the transmitter power and did some more tunings there.
Well, that's good to hear. So, so you're going to have hopefully less pauses. I see one of those robots is out there near the two park benches and right on the edge of that hill where where one of them seemed to like yesterday, and one's on the other side where number 2 liked yesterday. So, and it's still looking around for it, and number 2 is still out there. Looks like it's trying to make a friend with the barrier of where a trash barrel is placed sometimes.
Yeah, maybe. But right now the only hope is with the robot that has the sample. The other ones have no chance because they can't collect the sample from the other robot.
Right.
So, and the other robot doesn't release it before it decides that it's now in the home base.
So once it gets to home base, it's going to let it go?
Yes. Because by the rules, the sample should be easily removable by the judges. And if it's in our claws in the front are actually very, very strong. Yep. They grab the sample quite. It's soft but hard grip, so it's actually quite hard to remove it if it doesn't release it by itself.
Okay. So, did you guys design the body for these robots, or did you buy them off the shelf? What do you do?
We designed pretty much everything. Everything is custom designed. We bought the nuts and bolts. but
Okay.
Pretty much everything is like CNC engineered and machined with water cutting and.
So you have a bunch of markers on the platform, so you can approach it from any direction. And
Yes,
see it?
any direction, and the large ones are designed to be noticeable from quite far away, and but they are not very accurate. And then the small ones, they are used in close range navigation when it actually tries to enter the home base. And right now, here in level 1, it's fairly easy because it's just one sample. And there's ample of space to just drop it there. But in level 2, when there's multiple samples, and by the rules, you can't let them contaminate each other with like bacteria or whatever other things. So the samples shouldn't touch each other. So we have quite stringent bins on the starting platform where it should drop each sample, and that requires substantial accuracy in driving into the home station with maybe like 5 centimeter, 2-inch accuracy, and for that we need the smaller markers.
So the smaller, finer grain markers let you get that.
Yeah, it's still not good, but I think it's good enough. Yeah. But right now it seems the random search algorithm is still too slow to successfully find the home base. From 50 meters distance in 20 minutes time.
And how much time is left on the clock?
Minutes.
About 11 minutes are left.
Yeah,
Let's see how they do.
So I think it's still doable with the luck, but by now I think it's more luck.
Well, at least you have accomplished your objective of having the robot go out and collect the sample. Now you just have to make sure it understands like a bad dog. It's like, okay, well you have the ball, now bring it back, it back. So,
yeah, I think most of the mission is done successfully for us.
That's good.
Most in terms of what's hard for us. I think grabbing the sample from steep terrain was the hardest thing for us.
Mm-hmm. So you got to be happy with what you've accomplished.
Yes, but of course, we want to win as well, and you can't win by doing what it's doing right now.
Well, I'm sure there was probably a lot of cheering back in the pit areas when they saw your robot actually collect the sample off the hill. So,
Yeah, I'm very happy that it successfully collected the sample. That's like, most of the mission.
so you have two robots still looking for a sample, and you have this third robot trying to find its way back home. So the wheels, you said you have odometers on the wheels, or?
Yes, well, actually we have custom motor controllers, and we get all the feedback, very accurate feedback on the position of the wheels from those.
Okay, so it's just a little bit off on where it thought home was because of that, or
No,
is
not,
there a different routine? for it?
I think it's certainly not because of that. I think the most likely reason is that it thought it saw a visual marker
Right.
somewhere. I don't know. It might be the fence there. It might be, a fence also has those dark circles or something like that.
Yep.
A little bit similar to what we have
Yep.
on the home beacon. So
Right.
in our tests, sometimes the fence confused it. We did a lot of improvements on that last night, but maybe not enough. But go for it.
What would you say?
I would say that, be less conservative with your random search. Like, go longer stretches. I actually made the stretches shorter last night because I discovered that before that we made like 20-meter stretches, and then it turned, and then it went on another 20 meters in its random search pattern for the home station. But now I reduced it to 7 meters. So that it would have a better chance of actually seeing the home base if it's actually very close. But if it's actually quite far away, right, like it is right now, then a longer searching stretch, like 20 meters, would work better.
I mean, so far, do you think the bots are performing as expected?
They are performing as expected, with the exception of thinking that the home base is in the wrong location. Now it's essentially doing its backup routine in just this circumstance, but it seems that the error was too big, like 50 meters off, and to correct that, it's hard. I think if the judges would not stop the robots, after 30 minutes, we have batteries for 3 hours.
Okay.
So if they would actually let it continue for 3 hours, it would eventually actually get there. It's just race against the time, and right by now it's like almost hopeless. By now I think we don't need just a lot of luck, we need a miracle. But I think we should still wait for the miracle, right? We shouldn't tell the judges that turn it off.
if we could.
The miracles could happen. It could happen.
You got to be feeling pretty good because, so far you're the first team this morning to actually reach the sample.
Yeah, I'm very proud of it.
Did you feel like you learned anything during the competition?
Lots of things. Like, don't leave things on the last minute. We thought we knew it. I think all of the teams here, came here with the understanding that all the other teams, they make such trivial mistakes and they leave everything in the last minute. They don't check their last minute code changes and things like that. We are better. We can do it. We have, checklists, and we do prepare everything a week before or something like that, and they fail just the same way every time, just like us.
So preparation and paying attention to the details is the key to winning competition like this.
Yeah, I think the Stanley team that won the DARPA Grand Challenge, I think they had their robotic car pretty much completed about 1 year before the competition, and they spent the last year, just tuning and testing a little bit, and they won. And I guess that's the way to win. We understood that the competition is open for us, being non-U.S. citizens, we understood that we initially understood like a year ago. I was aware of the Centennial challenges, but I thought it's just for Americans, so I couldn't apply. I couldn't do this.
5 minutes left.
I just learned 5 months ago that this is not the case. That I won't get we won't be getting the monetary award, but we can still compete. And then we realized that we can actually do it. We can actually try. That this is a competition that's ideal for us. This is something that we should be able to do, and we could try. But that means we had only 5 months to do everything, and you cannot do preparation on that level that everything's completed, or you 1 year before the competition when you just have 5 months.
One more question on the launch was, at this point, since you grabbed the sample, you won a technical award. So you can't ask them if that's enough.
About 4 minutes left, and at this point, I mean, you grabbed the sample, so you at least have won a technical award. I mean, is that enough for you?
Well, I think it's more important for us that we completed most of the mission. I think in terms of the money, I think in terms of the budget, we have spent far more money than the Technology Achievement Awards. So.
I think it's great because the competition really isn't about the money. The competition is
Of
about
course.
furthering.
Of course.
You feel like your bot has helped push that a little bit?
Absolutely. We have realized from the beginning that we won't be getting the big financial award anyway. We are doing for the achievement, for the accomplishment, for the advancement of the technology available to the mankind maybe, and that's the reason we are doing it, not for money certainly.
That's a great reason.
Maybe I think because of the money, because that we won't be getting the big award, and we wouldn't return next year. But let's see. Yeah.
Thank you very much.
Thank you.
So 3 minutes. We'll see if your miracle happens or not. And
Super miracle.
yeah.
By now it's super miracle.
Right. I wanted to thank you for Intrepid Systems helping them out last night with their robot, their power problem. That was very generous of you to give them one of the power supplies from your backup robot.
Well, I think we are happy to help. If it's actually very easy for us to do that because we had lots of spares. So if a team has a major problem like that and we can help them so easily, then by all means, of course, we're doing it.
Of course. So what are you going to look at when you get back to the pits with your robots today?
First, for the logs, why did it think that the home base is in the wrong location? And second, maybe after some sleep, we'll run some simulations of what would have happened if the random search pattern would have been different.
Well, hopefully you got some sleep last night.
2.5 hours.
Yeah, maybe you'll get some tonight.
What's the name of the robot that grabbed the sample?
I'm not sure. Actually, it was the second. The second that's Ake, and Ake means plow in Estonian. That's plow. That's the the thing that it was used in the old times for in the fields, farming. Yeah.
Like a snowplow.
Well, not actually.
Okay, not like a
we were
snowplow.
more thinking of ancient times and so forth.
Okay. So your robots each have a different name?
Yes.
Okay, what are their names?
The names are designed to be unpronounceable by Americans.
That's why I'm going to have you pronounce it.
Yeah, and so the first one is
Okay.
that means night in
All right.
Estonian, and so the second one is Ake, that means plow, the thing that was used in ancient times to tend the fields in farming, and the third one that's actually not in operation, that it's broken, is called Go, and that's thunder.
Okay.
And then the fourth one is called Sade, which is spark. So they all have letters in it that's not used in the English language, and that's by design.
I see. That's by design. Well, we're coming down to less than a minute remaining. It doesn't look like your robot's going to make it, but you do get a technical achievement in grabbing a sample, finding it, grabbing it, and going back to what it thought was base. And at least it's smart enough to know it wasn't home, so it didn't drop it. So We get the final countdown coming up. 3, 2, 1. And there's the closing bell. Nice job. Thank you for being here, sir.
Thank you.
Your team should be happy. Go reward them with some sleep.
Thank you.